Our next speaker is Dr. Stanley Kitchen. Stanley works for the Rocky Mountain Research Station. He's at the Shrub Sciences Lab in Provo. He is currently the manager of the Desert and Great Basin Experimental Ranges, and most of his work has focused on ecosystems of the Great Basin region of the western United States. Welcome, Dr. Kitchen.
This has been an interesting experience yesterday and today. I must admit, as I stand here, I feel a little bit like David Letterman that I owe an explanation, but mine is a little different than his. And that would be that this is the first of these events, this series of events that I've been able to that I've attended and chosen to attend. I won't blame it on anything but myself. I think that'll change in the future because it's been a very enlightening experience. Yesterday, Peter Weisberg, as part of his title, asked the question, can a historical perspective guide management of future landscape change? That a question has been addressed additionally in talks that we've heard here this morning. I will attempt to continue to address that question a little bit, and as we as a group develop answers to the question. Again, we're talking about the Great Basin. I have the fortune to work in a portion of the Great Basin. Much of what I do is in the eastern Great Basin. I'm reminded in this slide, and that's why I put it here, that it's the Great Basin is not one basin, but many basins, and interestingly, many mountains separating those basins. No two mountains and no two basins are the same. They are not replicates. We can do a lot with that all the same, but they are each unique in some way. In the eastern Great Basin, at least, this does not hold true in the central Great Basin and other parts. But in the eastern Great Basin, the forested systems at lower elevation, the PinyonJuniper, we've heard a lot about that so far. In middle elevations, we have a mixed conifer forest, sometimes with a ponderosa pine, a significant ponderosa pine component. White fir, Douglas fir, limber pine extends into this, some aspen, Rocky Mountain juniper, a variety of species. And that transitions into a subalpine forest of five-needle pines, either bristlecone or limber pine, mixed with, in some places at least, Engelmann spruce and more aspen. There's certainly not clear distinctions between these forests. They grade into each other, but I want to, at least mentally today, I think in terms of the three types. And now the title. After this morning, I hesitate whether it's a good idea to use the term historic fire regimes as templates for fire restoration in the eastern Great Basin. By that, what I intend to mean is not a target that we're working towards, but a glimpse of a set of processes that we're working to maintain forests of the past and ought to have functionality or utility as a tool in Connie's toolbox to be able to maintain these forests, maybe in different locations on the landscape over time, but it's certainly important to maintain a process. Therefore, it's important to understand how those processes at least have functioned in the past in maintaining forests over some variability in climate. I pose 4 questions here. What were the fire regimes that sustained these Great Basin forests across millennia of variable climate in the past? How fire regimes and forests changed in the recent past? That's a fairly familiar question and answer for most of us. What will Great Basin forests in the future look like, and how will they function? And what should be the role of management in shaping those forests? Very grand questions that if you can come up with the answers for, see me after. I'd like to have some. I borrow from a larger study that Emily Heyerdahl, Peter Brown, and Mark Weber and I have been working on since 2002. In this study, we looked at 13 sites in 12 in Utah, one in eastern Nevada, where we had gridded sites. So every 500 meters, we would put a plot. In each plot, we would sample the closest 30 trees out to 40 meters and then we would age those trees in order to get at the age structure of the various species, as well as we were collecting fire scars, and then opportunistically we collected fire scars, samples from fire scar trees in between plots. Just gives you a representation of where those study sites were. 13 plus about 5 non-gridded sites that went into that effort. Today, due to the restrictions of time, I'm going to talk about a single site in Great Basin National Park, since our focus is in the Great Basin. This is roughly the boundaries of that site, just north of Wheeler Peak. Certainly not randomly selected, because there's a paved road that switchbacks all the way up through the study area. Made it, you only pack a chainsaw so far from a road before you start knowing the difference. So that's how this particular site was selected. This is a portion of it in what is called Burnt Mill Canyon. That was, to begin with, a real good clue that was a good place to go look for scars. You can see a portion here of a mixed conifer. Many of the ponderosa pine that at one time were on this hillside are gone. They were logged off, but the stumps were still there with their preserving their fire scars, waiting for me to come. The park actually gave me permission to sample a certain number of live trees, which was a nice, fortunate circumstance. You see a little bit of mountain mahogany over here. So it's not all forested. Of course, we're standing on a slope that's south facing, close mountain mahogany shrub here. There's scattered PinyonJuniper on this slope, but certainly different than what we're looking at. And then looking up Mill Creek Canyon, again, mountain mahogany stands here. There's some lines like right through there where you see a difference in age, and some open stands. Some sagebrush grass with conifer invasion, mostly white fir, mix of aspen, subalpine forest up the top. The top is at about 11,000 feet, mixed conifer forest below. Here's the grid. These are unsampled squares. Are plots where we sampled where we found fire scars, circles where we did not find fire scars, triangles are where we sampled opportunistically fire scarred trees outside of the plots themselves. So a cluster here, and this would be Burnt Mill Canyon and Mill Creek right there. Standard technique, this is the kind of thing you look for, a fire scarred tree, in this case a snag. That's what we're looking to sample. Sometimes there's not much left there, but because of resin content, they preserve better than the rest of the tree, and you're able to still get a sample. And these are the products that we work with. If it's a live tree, we'll take as small a portion of the tree as possible, leave the tree standing, and still recover the fire record. If it's a stump or a log, we'll oftentimes take a full sample to take advantage of a record on both sides. For this site, this was distribution by species, mostly white fir, but substantial numbers of other tree species. This will take just a minute to explain. Each of these box plots are boxes are a different one of our plots. So here 11C is a high elevation point, and low is an indication of fire severity using some criteria that we established. We have a number of fire scarred trees, no real indication of cohorts, and that's where we get that low severity. So at this high elevation 11C, and we look again down here at 12C and 13C, those are our highest elevation. That's in spruce, limber pine stands, and in each case they're low severity. We have fire scarred trees and no indication of cohorts being established during that time. We kind of expected to see more evidence of severe fire with stand replacing events. We didn't find it at that highest elevation. As we come downslope, though, we see some indication that there were fires that tend to take out part of the canopy and open it up. So in 11D, 12D, we had a criteria for assumed mix. I won't get into that now. 13D, kind of the same, but some indication that there was some mixed severity going on. At our lowest elevations, like 11H and 11I, You see that they were essentially non-forested before 1900. There was no evidence of trees before that time, and very young trees, and still a good shrub component indicating that they were open shrub grass hillsides. I want to get to this one. It's a little bigger anyway. 13H. From the mid-1600s to when the fire regime essentially changed, strong indication of a low-severity fire regime, a lot of repeated fire, a lot of fire scar, no indication of cohort development during that time. But sometime in the early 1600s, there's strong evidence that there was probably a stand opening event where all of these trees originally established. Therefore, looking at it through time, we classified that as a mixed severity, but mixed through time. And the one tree that was of older age right here had the outside had eroded some, but had likely had been killed by that fire event, suggesting that over time, even what for a period of time might appear to be a low severity fire regime, over time could be considered a mixed severity. And then what we would take with that information is we would plot the location of where, on any given year, where we would there was record of fire. The small dots are where there's a recording tree, a tree that had previously recorded a fire and therefore was susceptible to record further fires, but did not in this particular year. So we look here, we see one record of fire up high in that spruce limber community type. Apparently was probably a very small fire, didn't go very far. In contrast, 1632, we have a fire scar in the PinyonJuniper zone down at the bottom. We have no record of any kind in the middle. And then we have quite a scattering of evidence for fire on up through the elevation, suggesting it was a widespread fire. It may have been, in fact, the event that started the Ponderosa Pine stand, which was in 11H, is right here. And but certainly it was probably burned through these areas that were historically non-forested, but therefore we have no record of any fire. So that's the kind of information we can get. We have small localized fires and fires that burn in larger extent, and you can't really calculate area burn because many of the fires apparently probably burned beyond the perimeter of our study area, and because of missing evidence. But you can get a relative idea of fire size. Again, a little later, so we have many more recording trees, and even in that case, it's still a very localized fire. All these trees were recording, none of them recorded the fire. Burnt Mill Canyon happened to have quite a number of fires that weren't necessarily recorded elsewhere. Here's one that clearly burned on both sides and likely burned the unforested area in between. After that, there were some as there always are, some questions about what was going on in this portion of our study area that Peter, Emily, and I, and Mark Weber had started on. And so I continued to sample in this eastern Great Basin area. So I added 6 sites, none of which are gridded, but they are targeted sites for just looking for fire-scarred trees. Here on the Deep Creeks, the House Range, the San Francisco Mountain, an additional site on the Wallen Mountains, an additional site on the Snake Range, to get a better idea of the eastern Great Basin. And so here's the 10 sites. They vary from Sinbad Springs, which is about, or it's less than a hectare in size, with 4 trees, to the Beaver River, right fork of the Beaver River, that had, I believe, about 167 fire-scarred trees. And some have longer temporal depth as well. But the bottom line is, amongst all of those 10 sites, even with few trees, there was a lot of fire everywhere. Now understand that this is a site composite. Each of these vertical lines indicate a single fire in a given year, and it's composited for a whole site, meaning there may have been only one fire in a small part of that site, and that's not distinguishable from a fire that covered the site. They each get a vertical line. So this says nothing about point fire return interval. It says nothing about spatial variability. It just says somewhere within that site there was a fire on a pretty regular basis through these. And because of time, I won't talk about climate impacts. There are some climate things going on, and it may, that perhaps are a little bit different, but we'll have to pass that for now, because I was really interested in the seasonality signature. And so what you do with many of these scars, because you're able to assess the location within the ring where the scar occurs, or where the fire, the injury occurs. Sometimes you're not, and we just classify those as unknown or undetermined. D indicates dormant, meaning it was right at the ring boundary. It may have been a late season fire after the ring had finished growing, or it may be a case where it's an early season fire the following spring before ring growth has been initiated. If you don't have anything but dormant season scars, you cannot distinguish between those two. But by convention in the Southwest, they're assigned to the following spring because of the preponderance of fire activity during that time of year. In the Northern Rockies and in the Northwest, they are by convention assigned to the previous year because of the preponderance of fires late in the season. What do you do in the Great Basin? Partway in between. Well, you hope that there are some other scars. Before I go on, you hope there's some other scars that, because not all trees are perfectly synchronized, that maybe if you've got a bunch of dormants and a few early season scars, then you could assign it to the following year in the early season. Or if you've got a bunch of dormant season scars and a few late in the ring formation, then you could assign it as a late season fire the previous year. What I want to point out here is this is across all 10 sites. 51% of the sites were dormant season. 51% of the scars were. This is a little over 2,000 fire scars for those sites are dormant season. 13% in the early wood, 70% kind of middle in the early wood, 14% in the late wood, 7% or late early wood, and 7% in the late wood. If we look at it on a per year basis, and this is just one site, we can line them up like this. And so here we got a couple of earlies, a few middles, and one late, and a bunch of unknowns. Here, on this particular site, there are lots of evidence in 1765, and they span all the way from late wood to dormant and a good bunch of early woods. But so sometimes we might assume from that was a fire that burned through much of the season. It wasn't just a single season fire. Whereas one like this was likely to have been a mid-season fire in 1694. Clearly would assign this one as an early season. This one either as an early or a mid or somewhere between early and mid-season. So looking at from that perspective now, we still had 31% of the fires. All we had was dormant record. We couldn't assign them to early or late. We had 16% of the fire events now. Fire event being a fire in a given year in a given location, as early, 12% middle, and 23% late. Now I make an assumption here that this 31% ought to either be early or late. They're not going to be middle, or they wouldn't be scarring very many trees in the dormant season. So if we just arbitrarily assign half of the 31% to the early and half to the late, we quickly see the implications of a bimodal seasonality signature, which is not something we would have predicted necessarily. Now that's averaged across sites, and I'll be honest that some sites favored early season, some late, and not necessarily in a predictable fashion. If we look at the modern lightning fire pattern, lightning caused fire pattern, we see a distinct mid-season signature based upon the activity of lightning and the condition of fuels. So the suggestion is that the historic, but based upon tree ring pattern and that of the modern lightning pattern don't agree. My interpretation from that is that there was something else igniting those fires besides lightning. Now, the records seem to indicate that early man was in the Great Basin for about 13,000 years, and fire was one of the tools they had. And the seasonal difference strongly suggests that these fires were being, many of these fires, not necessarily all, but many of these fires were human ignited. So what were the fire regimes like? They were dominated by low and mixed severity fire, but occasionally there was, depending on topography and other factors, there were places where fire, with very little evidence of fire and very old growth, and other places where evidence of high severity fire. Most fires were relatively small. Fire seasonality was somewhat bimodal, with early and late season fires dominant, and to some degree fire was synchronized regionally by climate. How those fire regimes of forest changed in recent years. First of all, we don't have the fire regime we had before, but that's common throughout the West. We certainly have longer fire intervals, subject to higher severity. The seasonality distribution is different. Tree densities have increased, and we see forests expanding into non-forested areas. We heard a lot about that yesterday. And the main, perhaps one of the main points is that landscape heterogeneity has been lost, and that point's been well established too. So what will our Great Basin forests of the future look like? We're looking at here pre and post burn of a fire that burned in 2000 on the west slope of the Snake Range. It started in PinyonJuniper forest. It smoldered there for a few days. They left it alone, thinking that was not a big deal. Weather conditions changed. It blew up, and it raced to the top of the mountain, stopped at tree line at just about 11,600 feet, burning through a mixed conifer forest and the largest stand of bristlecone pine on that mountain. There's still a bunch of it. There's still some of it left, but much of it was taken out, and this is what it looks like. There are other options. Again, we're looking at here a logged over mixed conifer area that before and after burn. Is this the future of our Great Basin forests? Is there a role for shaping those forests? Here, the impacts of possibly lighter severity fire. Can fire be used as part of the toolbox to add resiliency to these forests wherever they may move to on the mountain or otherwise? And the other part of my title was about how to eat this elephant, and quickly I'll review a few key points. I'm about out of time. Strategies to restore fire should focus first on those mid-elevation stands of mixed conifer forest and degraded shrub steppe where fire, the changes have been the greatest. Here, this particular area, based on our fire scar record, was actually a ponderosa pine savanna with a fire return interval from 1400 to mid-1800s of about 12 years. And shrubs increased, and now trees are increasing in their place in the last 150 years. So very close to the same kind of location here, though we have a stand of ponderosa pine that happened to not get logged. Early and late season prescribed fire, following the pattern whether it was human or natural, should be integrated with mechanical treatments and native plant seedings to accomplish field modification and restoration objectives. And this guy, I think, posed just for me. Frequent small burns that mimic historic processes will aid in fostering public acceptance, critical if we're going to use fire, and reduce the risk of catastrophic fire and promote landscape heterogeneity. I'm done. Did I make it?
Some questions for Ben?
Dan, so the question is, why prescribe fires in other seasons rather than just kind of a midsummer one? Do you think that'll increase landscape heterogeneity, or?
The question is why use prescribed fire in other than mid-season, which is the time of year that we currently see most of our fires are larger fires. There's different ways to answer that. One is, if we're going to do prescribed burning, that's probably the only time we're going to be able to do it with any kind of success and control the fires. So that's part of the answer. Another part of the answer would be is based upon the historic record. That's when a preponderance of the fires were occurring for a long period of time. At least the length of time of the record that I have available to me, there was a significant portion of the fires were in early season fires and late. Now, I can't put dates on what that means because the tree ring doesn't give us dates. It just gives us an indication of likely early season or late season fires. So that allows us to control where we burn more precisely. It doesn't remove as much fuel, as much carbon, so to speak, but from the systems, so it takes repeated burns probably to accomplish the same end, but it does it in a stepwise ways that's a little more carefully done. Is that it?
Let's say that Clovis didn't cross the Bering Strait, and that we didn't have Native Americans until Europeans arrived. Do you think the vegetation would have been very different if the fire regime was basically midsummer, nothing else?
Are you saying in a general way throughout wherever?
Well, say in your area.
Boy, you're setting me up on that one, aren't you? The question was, do I believe that if the European man was the first man, or about that time was the first time humans got onto this continent and had an opportunity to impact the vegetation, would the vegetation have been different than what was found in 1492? Does that capture the question pretty well?
Sure.
Yes, I think it would have been vastly different. That's another talk to give further answer to that question, but yes, I think so. Were there exceptions on the landscape that would have not been so different? Yes, absolutely. But in a general sense, across the continent, I think that there are largely there have been significant differences, and in these areas that I'm addressing, I think some of both, but certainly I think that portions of this landscape that I'm looking at appear to have a clear human impact.
Now, when you say early season fire, you're looking at the secondary growth of the wood. About what time does that start in your experience, and how accurate is that across broad landscape scale?
Well, if you're talking about when a tree ring initiates its growth, it's going to be dependent upon local microsite kinds of things, such as slope and aspect, those impacts on temperature, elevation certainly, tree species, and then variability, genetic variability among species are proposed as influences on how much variability there might be. My experiences have been in these mid-elevation sites when I'm coring trees in mid-June at this latitude. When I'm coring trees in mid-June, they have not yet initiated ring growth. By first part of July, I'm starting to see some evidence of a new ring. So somewhere between mid-June and first part of July, at mid-elevation north to northeast facing slopes, is when that ring initiation typically would start for most trees. So any time before that would be when you see an early season scar, and then by mid-August, sometimes a little earlier. Certainly in a dry year, it can be much earlier, but in an average year, by mid-August to late August, ring growth appears to have been completed.